Yeah, welcome to Saturdays and EVs. Been a while since I've done anything, but this week I have jumped in over my head. I'm probably going to need a little bit of help here, but it is for a project that I've been working on and pondering and trying to figure things out. I am building an electric car. It's a little open-top roadster, a little Volkswagen. Be 192 volts when we're done, and I do run, it's all DC, and I do run a synchromotive controller, which I'm sure many of you have heard me say it is also a charger, can be used as a charger. It was designed that way. Run the power back through a lower voltage than your lowest pack voltage, and then run that through an inductor and then back into the battery pack. At any amperage level, you can set your voltage to cut off at a certain voltage, so you have like 3.55 volts per cell in your pack nominally at the end of charge and all that. It does the constant current, constant voltage, or you can just set it up that once it reaches a certain voltage, you can just have it shut off, and that's good. It is basically set up for the constant current, constant voltage, which I think is fine, and I think we're going to leave it that way unless we do some fast charging with it. The controller can handle the amount of amperage that controller can dish out. It can also turn around and run it back through the opposite direction back into the battery pack. So we can take a low voltage, ramp it up, and we can jam some pretty high amperage back into the battery pack. In my field testing that I've been doing, the highest I've had it was 150 amps into the pack. The last round, which didn't allow me to have a lot of amperage, was using my old DC welder. Gave me 45 consistent amps back into the battery pack, measured at the battery pack. So it's actually doing, it does quite well. What my goal is I was inspired by Jehu Garcia and his little Volkswagen bus towing charge that he did. He had his buddy tow him, put his bus in regen mode, and charged his battery pack. Well, that gave me an idea. I want to take it to the next level. Rather than towing, why not just hook an engine to one of these AC motors? Hook a controller to it, set the controller up for regenerative braking. You can adjust it, set it, whatever you need to do. Put it all on a small trailer and fire the engine up, spin the AC motor, run that sucker in regen mode, and instead of putting power into the motor, we're sending power out of the motor and into the battery pack. Now that does present a problem for my car setup. My setup's going to be 192 volts. It's not going to be like 96 volts or 144 volts or anything like that. So since my synchromotive controller can do charging, I can take that lower voltage, run that voltage that's coming off of this motor through regenerative braking function, and run that into the controller on my car through an inductor. My controller will take that power, boost it up, drop a little bit of amperage, but it'll boost it up, and if this thing can pump out some good amperage, we can dump some pretty high amperage back into the battery pack. And the goal is to have a fast charge generator that you can carry along with you that's fairly lightweight. It's not going to be huge, and heavy thing, and will allow you to unhook your trailer if you need, just tool around town. But if you need to take an extended trip, hook up your gas engine, your generator, take it with you, so when you need it, you can charge up without having to go find a charging station, which typically right now are level 2, so you're going to be waiting for a few hours anyway to charge, versus maybe being able to do a little bit faster charge. And that way you can open up your distance, extend your distance, basically turn it into a little hybrid trailer. Not going to give you regen braking on your car, but you could charge it. That's the goal, without having to spend $12,000 on a whole new battery pack. And that brings another issue too. A lot of people who convert their cars are converting small cars. We're limited in size in our battery pack. We don't have the physical size. We don't have the ability to put in like an 85 kilowatt hour battery pack so we can get 300 miles per charge. So to extend your range, what do? Well, you either don't drive, you take your gasoline car, or if you happen to have something that works, maybe a range extending trailer. Knowing that these things can do regenerative braking, and knowing that they can regen at a fairly high amperage rate, hooking these up to an engine, using the controller to control this, so we don't overvolt, overamp, over any of this kind of stuff, and have our own charger. All the software is done, all the hardware is done. Just off-the-shelf parts. Pick the parts. And now the thing is, we've got to pick the right parts. I'm not going for absolute perfection here. I'm looking to see if it's going to work, and to see if we can get a reasonably fast charge for my little Volkswagen. And if it works, that's going to be great. That's what I want. Then that will extend the range of my car to whatever I have gas-wise. Hell, I could even carry a 10-gallon gas tank and drive 300 miles. If I had an extra synchromotive controller or a way to boost the power to put it all back in that battery pack, do it while I'm driving. But that's not the goal. The goal is to have a charger. You drive, you stop, you charge it, shut it off, drive, until you run out of power, and just keep going in jumps, just like you would go a long distance or go a distance, stop at the charge station, charge it up, go again. That's the intended purpose. This is kind of a small motor. It's a 6.3 kilowatt AC induction motor. I believe we can get more out of it than 6.3 kilowatts without killing it. And even if we can get 12 kilowatts, that's a pretty good charge rate. Won't have to be spending all night long. Might have to wait a little while, but it's a start. Small motor. Bigger motor would work even better. But want to do this without breaking the bank. Want to do it for fun. See if it works. The other thing, this motor right here, it's a Raymond forklift motor for a drive motor. This thing looks almost ideal size for doing an electric outboard conversion. It's not too big, it's not too wide, it's AC drive, quiet, no brushes, none of that stuff. Looks like it would easily fit underneath the standard engine cover. So like maybe go out and get an old Mercury outboard, get one of these little puppies and hook it up. And off you go. Put it on your classic little classic aluminum boat. And I saw a really sweet one. And I'm going to go back and check it out. built for an outboard, not for an inboard. That might be also another project for this motor here, besides a generator. Could possibly fit in a motorcycle application. But anyway, my goal is to do the generator for range extension, and I see no reason why it won't work, because if you can pull a car and charge your battery pack, you can put an engine on this thing and do the same thing. And instead of pulling it, we're just running the motor with an engine. All there is, nothing different. Figure a way to hook it all up and let her roll. So I'm going to need some help. I do need a controller. I don't even have to have a big one, but one that I can change some parameters on. So I am kind of hoping to see it, and I'm going to talk to Brian over at HPEVS and see about getting a smaller controller that might control this, one that has the updated functions, so I can change some parameters on it to see if it's going to work. I'm going to pitch him my little idea here and see what he thinks. I do know that some of the Raymond forklifts use Curtis controllers, so I do know that they will work. So it's not like it's just going to be a shot in the dark to see if it's going to work. I do know that it will work. So I'm not hard pressed to like get a 96 volt 650 amp controller and give it a shot. I think that would be ideal, and I think this little motor can do it. If not, if you think it's too much, okay. If he thinks it's too much, okay. They run AC 20 motors, they run AC 15 motors on these bigger Curtis controllers. I see no reason why we couldn't set up some parameters and make it work. So I'm going to pitch the idea to him, see what he thinks. I think it's going to be a good shot. And so we're going to take Jehu's idea and take it to the next level. And if it works, somebody who's got a 96 volt system, you know, they might even be able to have a setup where you just have an extra plug coming off, extra wires off of your normal your AC controller. Have a motor, have another AC 50 motor or something like that sitting in the back, hooked up to a little engine, and just use the controller you already have in your car. So you stop, and you're not going to run the one motor that you have. You disable that one and run this one, charge it back through your system, and that way you have your range extension. Not while you drive, but you do have a range extension. Stop and charge, stop and charge, stop and charge, and it would work. And if these things can pump out the amperage like I think they can, our lithium batteries can handle that. So we should be able to pump some good amperage back through without killing these little motors, because they run that kind of amperage just driving the car. So I think it's worthy of giving it a shot. I think that's going to be about it. I do like the motor. It's a solid motor. It's got well-built terminals on the end here. Well protected. It's got a nice hard solid steel case with a lot of vent holes. It has these little tabs that attach to this hard metal case and clamps the end plates to the case, rather than having these long bars all the way across here. Does have the encoder for the encoder bearing on the back end. It is a double shafted this one's a double shafted motor, so other things can be run. This particular setup actually off of the forklift would have an electronic brake. Hit that brake and it stops. And it basically is kind of like a parking brake type thing. And the other thing I noticed too on this particular motor is the case on it was varnished as well. It's kind of got that orangey hue to it, orangey brown, and but it's got a straight shaft on the back with a keyway and a screw. It's got a taper shaft in the front with a keyway. It's got a pretty nice face plate right here to mount up. And I also have a nice set of contactors that I picked up. It's a set of 3. These contactors are 24 volt contactors. They're not the typical 12, but these are fairly robust. They're 300 amp contactors. About the same size as the, actually a little bigger than our standard fare here. Our little Kilovac EV200s. So I'm actually kind of liking these. I wish they were 12 volts instead of 24. So maybe somebody can enlighten me on why the forklift would use 24 volts versus 12. What's the benefit of 24 volts system versus 12? I've noticed that before. Some of the old contactors I had for the starter generator, they were 24 volt, and I still have those. Real pain in the butt. You got to find your 24 volts and all that stuff, and I can do it now because I have the DC converter that can do that. But anyway, this motor here, very nicely made. It is a Raymond forklift motor. I've already looked up the serial numbers and model numbers and all that kind of stuff, and quite a very solid thing. So here, between these vent holes here, this is all the workings, inner workings of this here. So we have a little bit on each end. That's the non-working part of the armature, just where all the wires, after they wind everything, kind of stick out a little bit on each side. And but looks like it's done well. These are made down in Juarez, Mexico, and they are Raymond forklift motors, not an aftermarket. Well, it is what they use. And the guy that I bought them from says what they do is Raymond will have these forklifts. They commission them for about 6 years, and then they devalue them. They take them apart, dismantle them, and sell them off and go buy new ones. And so these have a working life of maybe about 6 years, and then they get shit canned, and then they go buy new ones. Perfectly good motors, nothing wrong with them. This one was the nicest motor that the guy had. Picked it up for almost nothing, so it's good for a try. And if it doesn't work, no big chunk of change out of my pocket. And that's the good thing. But it'll still be a usable motor, so we'll be able to find something to do with it. But I'm betting a lot that we're going to get some power out of this thing for charging our car for an extended range trailer. So there you have it for this week, the extended range trailer project. That's what this is going to be. So with some of you guys' help, I've got some money to get a controller for this thing and get things set up and get this thing going. I've got my engine sitting over there, get that sucker fired up, but I do have to figure out how to connect the two together. So I'll be working on that. and I'll get around that hurdle, and we'll get something going here and see what we can do. And got some pictures. I'll toss pictures up. I think it's going to be a great project. So until next time, Saturdays and EVs, there will be more to come. Okay, just wanted to give you a little close-up of the motor. Let you kind of see what that looks like. Get a good view of the face of the motor. It is a slightly tapered shaft here. It does have a keyway and a little bolt on here. So you got a plate here and a resting face here. So we got to figure out some kind of an adapter plate to connect this directly to an engine, or mount these up side by side and run a big pulley. I'm looking more like running it straight off the crankshaft or straight off the flywheel, off the Volkswagen engine. There's the back side. These are the encoder wires here for all that, so I know it's going to work. It's got a standard, looks like a fairly standard plug. There's 4 pins there. There's another one that's got 2. Not sure what those are. I'm not seeing an internal fan, but there may be one up by the front here that I can't see that's underneath an item here. I'll have to get a small flashlight, look way up inside there to see. So got your terminals. All that good stuff. Your little pins here to crank your end plates on either end of this body. I like the design better. I don't like the wires. I don't like the heavy mounting bars that go all the way across to connect the 2 end plates on the AC75 that HP EVS puts out. But I'm hoping that this is going to work for our project. And then down here is our little contactor plate. So I guess depending on what kind of a load you're putting on this thing starts out at 300 or 150 amps. This one here, click. Need more load, click. Takes more, and then another one takes even more. So this is a 500 amp fuse, 150 amp fuse, and a 350 amp fuse. These are marked FU1, 2, and 3, and then there's TP3, TP2, and TP1, and then this is TP5. On the motor, we've got W, V, and U on the terminals, plus the encoders. And so that's the setup there. There's an old set of batteries back there that I used for charging, a fast charge on my setup. And over off to the right there, you can see a stack of solar panels that's going to be going up. Doesn't look like I'm getting them on the house, but I'm going to see about getting some of these up on my shop. Our concrete guy's coming to put our slab in here in probably the next 3 weeks, and we'll be all set with that. That'll be about the same time I'm going out for foot surgery, so that's going to be good. That'll work. More Calb SE batteries. The box that everything's sitting on is full of Calbs that I got, and they're all going in the little bug out in the back. Got some other motors sitting over there, ladder, motor, all that good stuff. So anyway, I'm waiting for a seat for my little car. The seat that you see upside down there, the maroon one, isn't going to work. The seat that's further over to the right, upside down, is dead. Came out of the car. That was the original one back in the 80s. So anyway, we're pretty much got the bugger ready to roll for some quick tests, and then we'll permanently mount the controller and everything in it. And just waiting to get that seat so I can get it rolling. Drain the battery pack, run it around a little bit, charge it up, drain it, run it around, charge it up a little bit. So that's the goal. That's my garage, and we will talk to y'all later.